Welcome to my YouTube channel. I am Associative from the Faculty of Computer and Information System of Ghana Communication Technology University. I'm here to talk about cache memory and how it functions. Computer has two types of memory. One type is used in the RAM modus, which is DRAM or dynamic RAM. DRAM is memory that uses capacitors to store data, and these capacitors has to constantly and dynamically be refreshed, often with electricity, in order for them to store data. There is another types of memory that computer uses that doesn't constantly have to be refreshed, and this memory is called SRAM or static RAM. SRAM is what is used in the CPU cache, and because SRAM doesn't have to be constantly refreshed, it's a lot faster than DRAM, and it's also very expensive. That's awesome. The CPU cache is CPU's internal memory. Its job is to store copy of data and instructions from the RAM that's waiting to be used by the CPU. CPU cache holds common data that it thinks CPU is going to access over and over again, because the CPU needs to access certain data. It always checks the fastest memory first to see if the data it needs, and if not, the CPU would have to go back to the slower primary memory or RAM to get the data it needs. So that's why cache memory is so important. Therefore, storing the commonly required data in the cache is beneficial to increase the computational speed. And therefore, there are three types of cache. You have the level 1 cache, level 2 cache, and level 3 cache. The level 1 cache is the smallest. It is located inside the CPU or the processor, so it runs at the same speed as the CPU. Level 2 and level 3 caches are external. In modern computer, level 2 cache is also being located inside the CPU. Level 2 cache is larger than level 1 cache. Wow. If the required data is not available in level 1 cache, the CPU checks the level 2 cache. Okay. If the required data is not available in both level 1 and level 2 caches, the CPU checks the level 3 cache. If the required data is not available in any of these caches, the CPU will access the RAM. Level 1 cache is the fastest cache of all. That's awesome. A CPU can have multiple cores. A core is the execution unit of the CPU. Each core can have separate level 1 and level 2 caches. The level 3 cache is the shared among all cores. Come to talk about the speed. RAM is faster than the secondary storage medium, but it's not as fast as the cache. Although RAM is expensive, it is not expensive as a cache. The capacity of cache is smaller than RAM, which has a higher capacity. The cache holds frequently used data by the CPU. RAM holds program and data that are currently executed by the CPU. Both cache and RAM are volatile memory. The difference between cache and RAM is that the cache is a fast memory component that stores the frequently used data by the CPU, while RAM is a computing device that stores data and programs currently used by the CPU. In brief, the cache is faster and expensive than memory. Thanks. Bye.
Okay. Hello. My name is Asante Bismarck, a computer science student in Ghana Communication Technology University. Okay. In this video, I'll be talking about cache memory. So if you having some form of misunderstanding about cache memory, the way it works, the types of cache memory, and other stuff about cache memory, I think this should be your final stop to this problem. Without wasting much time, let's get started. So, the cache memory is a type of computer memory that is used to temporarily store data that a computer is expected to use again. So, it's a form of volatile. Okay, when we say something is volatile, like it's not temporal. Okay, it's not permanent, it's temporal. Okay, like it stores, let's say memory is volatile, that means the memory stores data temporarily. Okay, like it's the form of temporary, form of memory. Okay, it stores data temporarily. Okay, we have various types of memory. We have the DRAM, SRAM, you understand. So the cache memory is a volatile form of memory. Yeah. So let's continue. So as it says, the cache memory is a type of computer memory that is used to temporarily store data that the computer is expected to use again. So it's like a user performing instructions on the computer. Okay, the cache memory trap all those kind of instructions and all those kind of data in one component. Okay, like it stores those stuffs. Okay, it stores them temporarily. Okay, whenever the computer, like whenever the user want to perform the same instruction, the computer is responsible for providing the instruction again to the user, and those instructions are backed, or let me say they are backed up by the cache memory. So the cache memory support the computer in that function. You understand me? Yeah. So it is faster than the main memory, the RAM. Okay, it's faster than the main memory of the computer. That is used to speed up the performance of the computer. So it's like the cache memory, it's more or less like the cache memory helps in the function of the CPU. Okay, it helps to boost up the function of the CPU. It helps to boost up the performance of the computer. So actually, the cache memory is very very fast. It's very very fast. So like it helps the computer to perform its function smoothly. Yeah. So it helps the computer to run at a faster rate. Hope you understand. Yeah. So it speed up the performance of the computer. I think you get it. Yeah. So the cache memory stores frequently used instructions and data for quicker processing unit. So the cache memory will um, stores frequently used instructions and data for a quicker processing unit of a computer. So the frequent instruction, as I said, when the computer processes different frequent instructions on the computer, that's the user. The user is the one who create that form of instruction. So the cache memory is the one that stores all those various instructions. Okay, the cache memory stores those various instructions, those frequent instructions performed by the user on the computer. Okay, yeah. So it's an extension of a computer's main memory. So okay, you see, we have every computer has this memory, and the cache memory helps to extend the let me say the speed of the memory in the computer. Let's say DDR3, 4 gig. Okay, it got it function like it's limited to a speed of rate. Okay, so the cache memory helps to extend that form of speed, that kind of speed of the memory, or allocated to the memory, or yeah, allotted to the memory. Yeah. So let's continue. So now these are the types of cache memory. We have the L1, L2, and L3 cache memory. So the L1 cache memory is the fastest and the smallest type of cache memory. It's normally it's built in the processor. Okay, so the L1 and the processor are built together, and it's the smallest type of computer cache memory, and it's also the fastest among all. And the L2 follows. The L2 is follows and is bigger than, let me say, is bigger than the L1 cache memory. The L2, is also very fast, but it's not that faster than the L1 cache memory. Okay, like they all get their standard. Okay, so the L1 is faster than the L2. The L2 is faster than the L3. You get it? Yeah. So the L3 cache memory too, um, just as the L1, L2. Okay, the L32 is bigger than the L2. Yeah, so they are all really fast. Yeah, let's continue. So I'm almost done. So like these are the briefly notes on the cache memory. We have several categories of computer memory, right? Which are grouped based on the generation, the speed, size, and cost. Yeah, so okay, every gen has its form of group of memories, the speed, the cost, the size. Yeah, so like generation one, Pentium one has its memory Pentium, and it comes to the DDR1, DDR2, DDR3, like listen, like any generation of any computer generation, any form of generation, okay, comes with its memory. Okay, so we have types of computer memory such as DRAM, which stands for dynamic random access memory. And DRAM is a type of random access memory. Okay, it's a type of random access semiconductor memory. Okay, that stores each bit of data in a memory cell consisting of a tiny capacitor and transistor, both typically based on a metal oxide semiconductor technology. You see, we have this transistor and capacitor on the memory. That helps to that those transistors help to convert the data and the bits. Okay, like the instructions saved on the computer on the memory. It helps to save them or change them to in a form that the computer will understand, so that it will be saved on the memory. Okay, so the capacitor and the transistor both help in the RAM. They help the RAM to function. Okay, so as I said, it's volatile. Okay, it's volatile like all RAM, and so it can't hold data without power. Yeah, so when your computer is on, that is when the memory is able to function. But when the computer is off, the memory is unable to function. You get me? Yeah, it's volatile. So DRAM is fast and comes in different speed and latency options. So the DRAM is fast, but it depends on it depends on the types of DRAM. Okay, it depends on the types of DRAM. Okay, and they all comes in various speeds and latency. Latency is the time delay between the moment something is initiated and the moment it becomes available for use. Hope you understand. Yeah, so like when you initiate something on the memory. Okay, so like the moment you initiate it, okay, and the moment it becomes available for use, that is what it terms at um, latency. So we also so I mean the DRAM, apart from the DRAM, we also have the SRAM, which stands for static random access memory. So this one too is a type of random access semiconductor. Okay, the okay, okay, so they are all form of semiconductors. Okay, they are all form of semiconductor that uses as for the SRAM, it uses latching circuitry, which is the flip flop. Okay, to store what do you call it, to store data, right? Yeah, to store each bit, let me say it like that, to store each bit. It is also volatile. Okay, it's just like the other forms of memory. Okay, it's also volatile. So the SRAM is more expensive than the DRAM and the and the other memories. Yeah, the SRAM is very expensive, and is within the SRAM we have the cache memory. Okay, and you see the cache memory is derived from the SRAM, and they are very costly. Okay, they are very costly. So they are mostly used in special purposes in computers and mobile phones and other gadgets. Yeah, so you see, this is the idea or topology behind cache memory. So I'm done. I'm done with you. Thank you very much. God bless you all. Bye.
Hello class, my name is Eric Akotoma. I am going to give a presentation on the topic bank memory. But before I proceed, I would like you to have the understanding of what bank is. Bank, in the worldwide known, is a financial institution that accepts deposit from the public and creates a demand deposit while simultaneously making loans. Therefore, in relating to what bank is, bank memory is a logical storage within the computer memory that is used for storing and retrieving frequently used data. However, bank memory provides a flexible way to allocate and manage memory resources. It allows the processor to allocate memory as needed, which helps to reduce memory wastage. Bank memory is used for various purposes, such as standard RAM and cache memory. Someone may ask, why is it necessary to have bank memory? These are some of the reasons. It improves the performances and efficiency of memory access by allowing simultaneous access to multiple banks of memory. It can also enable more complex and large applications to run on the same system. It is also a technique used to increase the amount of memory that a computer can access. In a computer, the memory bank may be determined by the memory controller along with the physical organization of the hardware memory slot. Thank you.
So let's discuss the method termed bank memory. You know, I want us to take our mind back to the concept of storage when we learned storage devices over the years. I mean, we have learned it so many times, but when we perform tasks on our machines, there is a hard disk and a RAM that will have to work together in order to transfer and store the data that we use or the normal stuff that we execute on the laptop or on our PCs and stuff. But there are within the storage within the hard disks and the RAM chips and stuff, there are like storage locations which are called registers. That's where like the data that we access is being kept, and there's a process in which this data, when like you execute an instruction or something and there's supposed to be information stored on the hard drive or RAM or any other thing that stores data, there's a process which is called addressing, whereby the memory location, which is also known as the register, are found, and then bits of information is stored in them. So it's more like when you execute an instruction and there's supposed to be memory that is supposed to be stored. It's the CPU sends instructions to the storage device to look for the memory location in which the data will be stored, and that process is what we call the addressing. And there's one thing, another keyword that we have to also take note of, which is the address bars. And this address bars is mainly the channel where the data is carried. That's the address bar. And the address bar, there are various sizes. There are 16-bit address bars, there's 32-bit, and there's 64-bit. And these sizes are what determines like how fast or like how much data the address bars in particular can transfer to the memory location. So this address bars in more systems that it's limited. Maybe let's say the 16 and the 32, they can't really carry a lot of data like that. Even if they will do it to slow down the PC and everything will look sluggish. 64 is a bit better, but if you are someone who does a lot of heavy workload on your machine, it might also not be enough, even though it is. But when there's overload on your machine, this is where the bank memory method was designed. It was designed so that in case of any clogged up or in heavy workloads, the laptop will be able to, our machines, our PCs will be able to function efficiently. So this is one aspect of when you look at the bank memory. It's mainly the segmentation, within the hard disk there are various segmentation, as in divisions of the memory locations, which is the registers. So in order for the memory to function faster, so that you don't feel slow or sluggish in your workflow, the system writes, which you can also use the addressing. It addresses the memory to the memory locations through these banks. So the bank, that's where the bank term is derived from. So when it contains various segments, so the CPU will send instructions to the bank that contains the information that you need at the moment, and then it picks it up for you as quickly as possible. Then it will make your work more easier. So that is basically what the bank memory concept is all about. Just finding a way to speed up workflow in our machine. So in more systems where the address bus is limited, as in it can't really carry a lot of information and stuff, it's just bank memory system that makes everything easier. So it's a lot that I've said, but that is basically what all this technique about the bank memory is about. It's not really a huge concept, but you have to just take note of some of the keywords, which is something like the memory segmentation, which is the division of memory into smaller segments or banks, like I said earlier, in order to overcome the address limitation. Which the address limitation is maybe instead of the hard disk just to be there like that, and maybe the CPU would just be writing instructions to it, just filling it up. It will either be better when there's more of like an organization. So the more organized the hard disk and the memories are laid out, the better the CPU recognize and send instructions to each of the banks that contain the needed memory. You see, it's not that now it's going to set through, you see, a long process to try to slow down the stuff. Yeah. So basically, that's what this slide is about. I'd like to end it here. Thank you.
Hello everyone, I'm Daniela Tumaku, and today we'll be talking about what an associative memory is. So we'll define what an associative memory is, what an associative memory is about, the type of associative memory, how it works, their organization, application and advantages and disadvantages. So what is an associative memory? Associative memory is a special type of memory that is optimized for performing tests through data as opposed to providing a simple direct access to the data based on the address. So what is an associative memory about? An associative memory is also known as content addressable memory, it's bracket CAM, or associative storage, or associative array. Associative memory can store the set of patterns as memory when it is being presented with a key pattern. It responds by producing one of the stored patterns which closely resemble or relate to the key pattern. It can be viewed as data correlation here. Input data is correlated with that of stored pattern in the camp. So for the type of associative memory, they are the auto-associative memory and the hetero-associative memory. For the auto-associative memory, it is the type of associative memory that is used to recall a pattern from partial or deduated input. In an auto-associative network, the output of the network is fed back into the input, allowing the network to learn and remember the path it's being trained on. This type of memory network is commonly used in applications such as speech and email recognition, where the input data may be incomplete or noisy. For the hetero-associative memory, it is a type of associative memory that is used to associate one set of patterns with another. In a hetero-associative network, the input pattern is associated with a different output pattern, allowing the network to learn and remember the association between two sets of patterns. This type of memory network is commonly used in applications such as data compression and data retrieval. So how does the associative memory work? In associative memory, data is stored together with additional tasks or metadata that describe its content. When a test is performed, the associative memory compares the test script with the start of all stored data and retrieves the data that match the query. So the associative memory is designed to quickly find matching data even when the test query is incomplete. This is achieved by using parallel processing methods where multiple test queries can be performed simultaneously. The test is also performed in a single step as opposed to conventional memory where multiple steps are required to locate the data. So for the organization of associative memory, as you can see the block diagram of associative memory. So the associative memory hardware structure consists of the memory array, loaded for n words with n bits per word. Several registers like input register, mask register, select register, and output register. So the application of associative memory. 1. It can only use in memory allocation format. 2. It is widely used in the database management system. 3. It is used in network rotation table to quickly find the path to a destination network based on its address. 4. It is used in image processing applications to test for specific features or patterns within an image. 5. It is used in database management systems to quickly retrieve data based on its content. 6. It is used in artificial intelligence applications such as expert system and pattern recognition. So for the advantages of an associative memory, it is used when test time needs to be less or short. It is suitable for parallel testing. It is often used to speed up database. It is used in page table, used by the virtual memory, and used in neutral network. And that is the disadvantages of associative memory. It is more expensive than RAM. Each cell must have storage capacity and capability, and